We're going to look at a related rates problem that involves a circular oil spill. We're told that oil spills from a ruptured tanker and spreads in a circular pattern. The radius of the spill increases at a constant rate of 1 meter per second. We want to find how fast is the area of the spill increasing when the radius is 30 meters. Now that we've read the problem carefully, we want to go ahead and fill in these 4 categories that I've listed here with the information from our problem. Since the oil spreads in a circular pattern, I went ahead and I put a circle down here for our diagram. We need to assign a variable to this. So if we talk about the oil spreading, we are going to be looking at how the radius changes. So let's go ahead and we'll put an R down there for radius. Now let's look at what we're given. We are told that the radius of the spill increases, so that is dr dt, at a constant rate of 1 meter per second. So we're going to set dr dt equal to 1 meter per second. Make sure to include units when you're putting down this information. We want to then find how fast is the area of the spill increasing. So that's dA dt. And there's always a when. The radius is equal to 30 meters. So we'll put a line here and say that is when R is equal to 30 meters. And now we have to find an equation. We want to find an equation that relates what we're given, such as the rate of change of the radius, to what we want to find, the rate of change of the area. So we need to think what formula that involves a circle has area and radius in it. And that formula is A is equal to pi r squared. Now what we need to do is we need to differentiate this equation with respect to time. Let's go ahead and we'll write down our equation. We have A is equal to pi r squared. And then we're going to take the derivative with respect to time of both sides. So we have dA dt is 2 pi r times dr dt. Both of these quantities are functions of time. Now we want to let our radius be equal to 30 meters. So we're going to find dA dt when r is 30 meters. So this is 2 pi times 30 meters times dr dt, which we are given, and we are told that that is 1 meter per second. So this gives us an answer of 60 pi meters squared per second. We can now say that the area of the spill is increasing at a rate of 60 pi meters squared per second.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.